Let's talk about 6-5 part 2. In this part we have story problems and also how to write an inequality given a graph. So here we have Ada has at most 285 beads to make jewelry. A necklace requires 40 beads and a bracelet requires 15 beads. So the first thing that we have to do is write an inequality that represents this situation. So if necklace beads are X, we'd have 40X, and then bracelets are Y, we'd have 15Y, and she only has 285 beads, so she can't use more than, so less than or equal to 285. So then I have my inequality. Now the next thing that I have to do is graph this. Now in order to graph it, I need to solve it for y. So let's go ahead and do that. Subtract 40x, subtract 40x. So then I have 15y is less than or equal to negative 40x plus 285. Now you gotta divide by 15. So then I have y is less than or equal to, this isn't even, but I can reduce it by taking a 5 out, so that'd be negative 8 over 3 x, and then 285 divided by 15 is 19. Okay, so now I can graph it. Remember we said that y was bracelets, so let's label our graph here. And x was necklaces. Now I gotta get up to 19 on my y-axis, and I have a slope of negative 8, so let's just count by 2's. And then the bottom here, I think we can probably count by 1's. So if we start at 19, that's going to be right here. We got to come down 8 and over 3. Then down 8 over 3. Okay, so our line is going to look something like this. Now, the reason that it doesn't go farther than that is because it doesn't make sense here for x and y to be negatives, because we're talking about necklaces and bracelets. So then the last thing I have to do is decide where to shade. Since it's a less than or equal to, I'm going to shade underneath. And again, the shading is only going to stay in the positive part of my graph, because again, it doesn't make sense for x and y to be negative. And then the final thing that they'll ask you to do is to give two combinations of necklaces and bracelets that Ada could make. And all we have to do is find some points in the shaded region. So let's say I have the point here 2, 2, 6. She can make 2 necklaces, 6 bracelets. And then another point here, let's just go up here, she can make 1 necklace and 12 bracelets. Okay, so those would just be 2 possible combinations. Now obviously on that part answers will vary, because you can just pick any 2 points in the shaded region, or you could even pick points that are on the line since it's less than or equal to. Let's look at another one here. Dirk is going to bring 2 types of olives to the Honor Society induction and can spend no more than $6. Green olives cost $2 per pound and black olives cost $2.50 per pound. So again, the first thing we gotta do is write an equation. Well, if green olives is x and black olives is y, I'd have to have the sum of those be less than or equal to, because no more than, $6. Now once again I have to solve this for y. So I'd have 250y less than or equal to negative 2x plus 6 divide by 2.5. Sorry, I'm going over the writing here. So then I would have y is less than or equal to 2 divided by 2.5, which is 0.8, which I think is 4/5 if we put it as a fraction. And then 6 divided by 2.5 is 2.4. Okay, so there's my y-intercept form. Now we said that green olives were x, and then we said that black olives were y. Okay. Let's just count by two. We can probably count by pretty small numbers here because we're just going up to 2.4. Let's just go here by sorry, I'm just trying to think of what I want to count by. Let's go by 0.5s, I guess. It's a negative 4/5, sorry. 1.5, 2, 2.5. So here I'm going to start at 2.4. It's going to be about right here. Now notice here that I put 4/5, but it doesn't work very well because I'm going to end up way down here in the negative. So like I said earlier, it was 0.8, so maybe that would be easier to use here. Usually it's not, but it might be in this particular case, so we don't get into the negatives. So down 0.8 from 2.4 would be 1.6 over 1. We'll just count by ones down here. And then again, down 0.8 would be what? We're at 1.6, so 0.8 over 1. Somewhere in there. Again, I draw the line through those points. And since it's a less than or equal to, I shade below. So my graph would look something like that. And then I have to pick two combinations, so we could do 1 and 0.5, and we could also do 2 and 0.5 if we want to. Okay, so that's what the story problems look like. Now the next type of problem you'll see is going to look something like this. It gives you a graph and it wants you to write the inequality that is represented by the graph. So in order to do this, remember we're going to have essentially y equals mx plus b, except for this is going to be an inequality sign here, and I need to know what m is and I need to know what b is. Well, b is where it crosses the y-axis, crosses here at 1, so b is going to be 1. Now if I look for another point here where it crosses at a corner, which would be down here, it looks like I have to go down 1, 2, 3, so my slope would be negative 3 over 1, 2, 3, 4, left 4, so that would be negative 4 as well, positive 1. And then, is it shaded above or below? Well, it's shaded above, and it's a dashed line, so it would just be greater than. Now I wouldn't want to leave both those negatives in there, so it'd become positive 3/4 x plus 1. Okay? So essentially what you need to figure out is what's your inequality sign based on the shading and whether it's dashed or solid, and then your slope and your y-intercept. Just look at one more here. So again, we're trying to fill out this mx plus b, and we're going to have to change this sign. So here, what is b? Well, b is -5 down here. What's m? Well, it crosses again over here. And this is counting by 2's here, so it looks like I have to go up 5 and then left 10. Now it's shaded below and it's solid, so that would be less than or equal to. And then if I reduce my slope here, it's going to be -1/2 x minus 5. And that would be my answer there. Okay? So those are the two things you're going to be working on in part 2.